Okay, I'm going to try to explain this the best I can. You basically have matter and antimatter. There really is no such thing as positive and negative. Antimatter is no different than our matter. It just the polarities are different. Whenever matter and antimatter meet, they annihilate each other. They basically revert back to their primitive state, which is just energy. So huge explosion. They the just unbelievable what small amounts will release. So Big Bang goes off. Uh, that it could have picked either which way. What it could have determined is its polarity, but our universe is our polarity. There could be another universe look exactly like ours, but it could be, uh, in our perspective, antimatter. But to them, we would be antimatter. If you're still with me, then imagine this. Say there really was time and space prior to the Big Bang event. They act like, well, they just come up with all kinds of different things. And as far as I'm concerned, they're all guessing. So here's my guess. Imagine that the universe is far bigger than anything we ever imagined. And supermassive black holes, just imagine them gobbling up half of a known universe. They're just huge. They've gobbled up till there's nothing left. The density of the density of this thing is infinite. You know the and it's just roaming around in completely dead space. There's nothing there. It's just wandering around in a void. Well, really far off is the same thing that has happened, but it's of opposite polarity. Antimatter to this black hole. So it did the same thing to its universe. In say I don't know 100 billion years or whatever time frame the long time. So these two black holes, which are opposites of one another, just so happens, in an infinite amount of time, they eventually get close enough to each other, start drawing each other in on the gravitational fields, and they collide. Well, that's just like on a small level, whenever we collide matter and antimatter, large release of energy, boom, two large supermassive black holes collide, matter, antimatter. I mean, the energy release would be, if you're still with me, equivalent to what we call our Big Bang and our universe is formed. They talk about multiverses and multiple universes existing. I absolutely believe that. I think our visible, they corrected how they say it. They talk about our universe as our visible universe because really it's just what light's allowing us to see. I think this thing is beyond big, and I don't necessarily believe that beyond our visible universe that we're separated by large voids. I mean, it could be, but don't necessarily have to be. I think they cluster. I think universes, use that term loosely, cluster the same way galaxies cluster. And there can be large voids, or like I said, groups of them really close together. I think you got to look at it like a fractal. The same way that in a nebula, when a star is formed, whenever the temperature gets high enough and fusion takes place, there's a large explosion and it pushes all the dust out, a lot of the dust out, and makes a big void in the nebula. You can see them. You can see when they're born. Well, I think the same thing happened if you were to say, hey, well, David, if that's the black hole things, how things happen, then why are there just such young stars and it took a while for heavier elements to be originated? Well, the same way, if you look, like the closer you look at the picture, the further you go out, it's always the same. Because just like in a nebula, this two black holes meeting was such a huge release of energy, it blew everything away, cleared everything out. So to us, it's like, brand new universe, but it's not really. It's just a clean slate for new stars to form and planetary bodies to form. Uh, if anybody else cares, I hope this gave you something to chew on for this week. But if you don't, then I'm sorry I wasted your time. But something to think about. Like I said, my guess is just as valid as anybody else's.